Good day! On episode 2 of Cooking with the Scientist, we are exploring the effects of salt NaCl ionic bond on water. So give me one moment as my assistants introduce themselves as I grab something off the stove.
I am Scientist Noah. Scientist Hannah.
Thank you very much. It's always nice to have guests on the show. So today we are going to look at boiling water and cold water. So right now what I have is one pot, Teflon pot, very good high quality pot. I put 2 cups of water in here. For those of us below the border, that'd be 2 cupos of agua. And I'm just, we were at over 100 degrees Celsius. In fact, it was at 103 degrees and it was boiling. So what we should know from studies already is that water boils at 100 degrees Celsius at sea level. Now we at say 1200, 1300 feet above sea level. So normally it boils at 94 degrees. So that's 9 degrees different. Whoa, what happened? It got hotter. That's kind of a big deal, okay? So that's once again, I put some salt in here. I put 1/3 cup for you American people that don't do metric. And for metric, that's 75 milliliters. Onto the cool, chill one here. So what I have, I give you a little glimpse. Ice cubes. Kind of like the American rapper Ice Cube. I put ice cubes and then I put a lot of salt. I just poured and poured and poured. But my temperature right now, you might even be able to see this because I use digital thermometer because my eye's not so good anymore. Check that out. That says negative. Oh, it's getting warmer now because I took it out. Let's go. We gotta put it back in. Put it back in. Let's mix it up real good. See how cold. And then I hit the button that keeps the temperature that it's at. Ooh, getting colder. Getting colder. Oh no, now it's getting warmer. Go the other way. They go in the wrong direction. Now we're getting colder again. Yeah. Oh, boom. Negative 9.2 degrees Celsius. Now, for those of you Americanas who don't know Celsius, that is 15.4 degrees Celsius. Excuse me, Fahrenheit. Look at me already, screwing that up. So, what we need to understand is this should by all means be frozen, but it's not. It's all frosty. Get all the frost on her, flick it in her face like you do on the bus. Take your fingers, get the frost, and then flick it at your friends. Don't do that. But with that in mind, we have 2 differences. We have water that's hotter than it should be boiling. We have water that should be frozen, but it's still liquid. So we need to understand what impact does salt have in that relationship. Remember, the salt is the solute. Do not eat the materials for our lesson. No. So, with that being said, figure out what the salt does. Why does it make it hotter? Why does it make it colder but not freeze? And with that in mind, have a glorious day. This also will be the final episode of Cooking with the Scientist. Food not very good. Later.
Can I put my